Ben Gertzel here. I'm going to tell you about one of the very most exciting initiatives in the SingularityNET ecosystem to launch since the beginning of SingularityNET in 2017. And this is Hypercycle, which is a blockchain, actually a sort of sidechain plus, a layer 2 network living off the side of Cardano and leveraging Cardano main chain. It's a custom blockchain designed specifically to meet the needs of SingularityNET's decentralized AI. And actually, while that's why we designed it, it can go beyond that. And Hypercycle can provide a very flexible, low cost, very scalable mechanism for all sorts of other applications apart from SingularityNET, but we're initially tuning it to serve as a custom blockchain underlayer for SingularityNET. So it's a bit different than the other SingularityNET, spin-off and ecosystem projects that I've been talking about for the last couple of years. Those run on top of SingularityNET, leveraging SingularityNET's decentralized AI, whereas Hypercycle runs underneath SingularityNET, providing SingularityNET with a efficient custom blockchain infrastructure. So let me share my screen and run through this all in a little bit more detail. I'm going to try to take half an hour or so and run through some of the particulars, not a full tech deep dive. You can look at the white paper, which dives a little deeper, but a moderately deep dive. So we're looking at how to scale up blockchain infrastructure to fully meet the needs of decentralized AI. I mean, at the moment, we're looking largely at narrow AI serving vertical market specific applications and AGI R&D, like our R&D on the OpenCog Hyperon project. And I think Hyperon is the blockchain infrastructure to get us from narrow AI through general intelligence at the human level. And maybe once we get there, maybe the AGI that we build on top of SingularityNET running on top of Hypercycle using OpenCog Hyperon. I mean, maybe that AGI will develop the next step beyond Hypercycle, the Hypercycle or the Psychocycle or whatever. But I think Hyperon can get us a long way. And I'm not gonna go into too much depth on SingularityNET here, which is of course the context in which Hypercycle, my main topic, for this talk is being developed. But I've given a bunch of talks on SingularityNET before, but SingularityNET is a decentralized blockchain-based AI network where you can have a bunch of AI agents owned and put online by anyone. They communicate by a common decentralized protocol. They can solve problems for external agents, or they can outsource work to each other or self-organizing into different groups to cooperate to solve problems. So it's a sort of society of AI minds, which can form a kind of collective emergent AI mind, and which is owned and controlled by no one agent. The whole collective is owned and controlled by the whole collective in a decentralized way. We have a wonderful community helping us to make this all a reality. I mean, there's a number of components to SingularityNET. The AGIX token is used for payment for services, for incentivizing development, and it will be used for reputation rating and a bunch of other purposes. I mean, the synergy between AI agents on SingularityNET is it's illustrated by this example I've given a few times before. I mean, if you have an AI agent to summarize, say, Word or HTML documents, it may outsource work to a text summary agent, may outsource work to a video summary agent, could be an audio summary agent, a natural language translation agent. The back-end collaboration of all these agents cooperates to finally summarize a document for the end user. I mean, this is a fairly simple vertical application. Now, you've got thousands, tens of thousands of such applications that we can put on SingularityNET. Right now, we don't have all of them, but I mean, we have some things in DeFi, we have things in genomics, a bunch of image processing, music processing. There's already stuff out there. All these specific AI agents, along with AI agents performing generalization, imagination, and reasoning using, core AGI algorithms like the ones we're developing in our OpenCog Hyperon project or other AGI architectures. The highly general abstract AI agents interoperating with the more specific AI agents. This is what can lead to an overall network with some measure of generality to its intelligence. And then in SingularityNET ecosystem, we got SingularityNET Foundation building the underlying platform, and then a bunch of other ecosystem projects building products leveraging this platform in areas like decentralized finance, medicine, decentralized media and social networks, decentralized usage of computer hardware, medical robotics with the amazing Grace robot manufactured by Hanson Robotics with SingularityNET-based AI built by Awakening Health. But all this cool stuff, you know, it runs in SingularityNET, but it runs on top of some underlying blockchain, right? And we launched SingularityNET on Ethereum blockchain because it was there. I mean, the core architecture ideas behind SingularityNET I had in 2001. I wrote about some of this in my book, Creating Internet Intelligence, in 2001. But until we had Ethereum smart contracts, it wasn't so clear how to really do it with a, you know, a tractable amount of effort in a reasonably compact and maintainable way. And Ethereum let us build the first version of SingularityNET, which is awesome, right? And since that time, I'd say, you know, the speed and cost of Ethereum networks has not been what we'd hoped, and there's good reasons for that. I think Ethereum has a good growth path ahead of it, but I've become quite enamored of the Cardano blockchain. I think Cardano has a really, really solid architecture grounded in fundamental computer science theory. I'm a big admirer of Charles Hoskinson, Cardano founder. And so we're in the process of porting SingularityNET mostly from Ethereum onto Cardano. Actually, what we've done is make SingularityNET multi-chain, so we can run portions of SingularityNET network on as many different blockchains as we feel like. But we're building a version of SingularityNET Marketplace and the other key SingularityNET tools on Cardano. Bulk of our development effort is going to go onto Cardano blockchain, and we're in the midst of doing that now. I mean, that's a project for this year. I mean, we have one version of the converter between the Ethereum and ADA versions of the AGIX token. One version of that converter is on the Cardano project's testnet already, and we've been looking at and writing some code toward porting more of SingularityNET, like the staking portal and SingularityNET marketplace on the Cardano. So that's great. But what I want to talk about here is the next step. I mean, porting to Cardano, there's still work to be done. It's a non-trivial engineering to be done in some cases, whereas Hypercycle it will be a bigger leap. We're not going to get SingularityNET running in Hypercycle this year in 2022, but it's in a way a more fundamental leap because it's shifting to a blockchain infrastructure which leverages Cardano, runs as a sidechain to Cardano, but is more particularly designed to meet the special needs we have in SingularityNET. And as I noted, though, by making a blockchain framework with the flexibility to be customized for SingularityNET, it ends up we're also going to be able to customize it for a bunch of other sorts of applications besides SNet, and I'll get to that a little later. So the motivations here, to put it more generally, I mean, beyond just, well, Ethereum is too slow and expensive. I mean, and I'm a total believer that we need to make global tech infrastructure decentralized, democratic, secure. I mean, we're heading toward a technological singularity where more and more of the global economy is on computing and communication networks, including ultimately the decision power behind the global economy, right? And I mean, in this context, we don't want one elite group to control everything. I mean, there's no one that can be trusted in that way. We want the control of this global computing and communication network to be with all the participants including all the users of this global computing and communication network. Blockchain tech is one of the keys to doing that, right? I mean, blockchain, it started with Bitcoin, which is digital money, but decentralized digital money, but blockchain network fundamentally lets you take any decentralized network of software agents and have it operate in a coordinated way without any central controller. So that's awesome. It's one of the main technologies humanity needs to get to a beneficial technological singularity. It doesn't play quite as core a role as AGI is going to play, but we need blockchain to make sure that AGI isn't co-opted by some elite group or by malevolent forces. And we also need blockchain just for ethical unrolling of narrow AI applications in the near term as we move gradually toward the singularity. But current blockchain tech does, it falls short of what we need in many critical ways. It's slow, it's expensive, it's awkward and annoying to use, right? And of course, there's a bunch of blockchain projects out there trying to overcome these obstacles, Cardano included, and there's a bunch of strong projects out there. I mean, I love Cardano, but Algorand is a very, very strong project. We've got Elrond. We've got a lot of good projects out there. But I think ultimately, when looking at everything around, I became convinced we need, if not a full custom blockchain, at least a custom sidechain to optimize blockchain to do with what SingularityNET needs. And this, honestly, I don't have enough time or to give or make the slides summarizing everything that's bad about current blockchain technology, but just a few highlights or lowlights. I mean, it's expensive to do transactions. It's slow. The whole infrastructure is set up to make hacks of various sorts far too easy. Smart contract bugs, economic attacks, all the crap you see in the news with this or that DeFi network hacked into here and there, right? And the whole existence of a ledger, like a common ledger across the whole blockchain, is just a little weird and doesn't necessarily work to all the goals of a blockchain, right? I mean, we're supposed to be doing stuff that's private and respects sovereignty and the ability to keep things secret when we want to avoid centralized takeovers. But yet in the current blockchains, I mean, every transaction you make is there on a public ledger that's copied over and over for everyone to see. Now, you're only identifiable by a sort of secret ID code, your wallet address, but it means if you don't want everything you're doing to be understood by people doing network analysis on the ledger, you need to awkwardly keep shuffling among different addresses and so forth. I mean, the whole setup with a replicated ledger at the center of each blockchain, which we're going to go beyond in hypercycle, it gives certain perversity in terms of how the privacy goals of blockchain can be achieved. So far, smart contract programming has been pretty awkward. I mean, Solidity and WebAssembly kind of suck. I think Plutus is a lot better, Cardano smart contract language, but it still needs some of the tooling layers to make it really fulfill its purpose. Until Plutus, I'd say we didn't really have a smart contract language obeying basic principles of modern computer science and software engineering. I mean, we have very, very poor composability among Solidity contracts now. And what that means is everyone's reinventing the same wheels over and over. Like the typical way to build a DeFi network, like you download someone else's code, you cut and paste, you change a few things in the code, then you launch it. I mean, this is not how real software products are built. This is what black hat hackers do when they want to hack into someone's website. They download some hacking script and tweak it and run it, right? But it's not the way things should be done to build the decentralized infrastructure of the emerging AGI global brain and the infrastructure of the next generation of the world's financial and social network and supply chain system and blah blah blah. I mean, you want a smart contract framework that allows elegant composability so people can write reusable modules, and when you're doing something new, you don't cut and paste, you reuse that module, right? And I mean, Haskell allows that. Plutus, which is a layer on Haskell, allows that. So we're a good step there with Cardano. I think we can take some additional steps with hypercycle. And core ideas here or the core themes here, let me say. In hypercycle, we're going to get rid of the replicated ledger, of the idea that you have this whole ledger of all transactions in the network and you copy it over and over. Replace that with a more sophisticated ledgerless system that still uses Merkle trees. Like, it still uses the core crypto math of blockchain networks, but without a replicated ledger spanning the whole chain. The notion of reputation, as in, say, SingularityNET's weighted liquid rank reputation system, the notion of reputation, I think, is key. I mean, going from proof of work to proof of stake is a step, but that's just like whoever wastes the most processor time and, you know, increases advent of global warming and heat death of the universe fastest can approve consensus, versus whoever's richer can approve consensus. I mean, so proof of reputation moves beyond that to whoever has been a better actor in the network can help approve consensus. And I think that's a natural next step. And then, as I already said, we need a more computer science driven, formal theory grounded approach to the smart contract languages. And, you know, as part of that, you can have a generic smart contract language, but most smart contract programming shouldn't be done in a generic smart contract language. Most smart contract programming should be done in domain-specific languages customized for a particular application. So if you want to build a DeFi system, I mean, you want to be using a DSL for DeFi. If you're building a healthcare blockchain system, you want to be using a DSL customized for healthcare. So the role of your generic smart contract language is largely to create DSLs, which make it easy to do development of blockchain applications in specific verticals. And we're pretty damn far from that with Solidity. We don't even have basic use of reusable modules today, right? But so putting these aspects together, ledgerless use of Merkle trees and proof of reputation and sophisticated sort of, or let's at least say modern computer science driven smart contract languages, including appropriate use of DSLs. Putting these ingredients together, you basically get hypercycle. And a little more depth, I mean, we're achieving these themes by combining a bunch of existing software components. Otherwise, this would be a 10-year project, right? So key here is the Toda ledgerless blockchain, which is invented by my good friends Tufi Saliba, who will be, along with me, leading the Hypercycle project. And Tufi's the TO in Toda, and then Dan Tolliver, the DA in Toda, who designed a lot of the core data structure and some of the algorithms inside Toda, and will be advising and helping us a bit on Hypercycle. So Toda, it's a secure decentralized communication protocol with some novel consensus mechanisms. Basically, it's a blockchain framework that doesn't need a ledger. It doesn't need a ledger that's copied all over the place, or sharded versions are copied all over the place. So it's a different way of chopping things up, still using the core encryption principles that have been around since Bitcoin, but the Merkle trees are arranged in a different way. And I'll talk a little bit about that. That's obviously very key to achieving the scalability and low cost that we're looking for in Hypercycle. I mean, the reputation part, we've done a lot of prototyping and experimenting on that in SingularityNET context. There's papers out there on the weighted liquid rank reputation system. We're not building a new standalone blockchain. I mean, we could, but that's more work than we want to do. And Cardano has done a lot of amazing stuff. So we want to leverage Cardano's Plutus smart contract language, which is really the only smart contract language out there that obeys sort of adequate modern computer science and software engineering principles. And then Cardano's Hydra framework lets you interface external networks with Cardano in a really slick way that lets you still run the Plutus contracts on the side chain, right? So it's isomorphic mapping from the side chain into the main chain. And that Hydra is really what lets you do something like Hypercycle. There's all these novel, weird things, but yet interfacing smoothly and isomorphically with Cardano network, right? And then the final piece is, on top of Plutus, I want to run the Meta programming language, which is the new programming language we invented in the OpenCog Hyperon project. And Meta lets you write smart contracts that are really customized for AI, and it's also really good for creating application-specific DSLs, right? So then by plugging Meta into Haskell alongside the code we're already doing to plug Meta into, say, Python and Julia, by plugging Meta into Haskell, you're able to plug this sort of AI-specific language of thought into Plutus, into your smart contract language. So we're putting together a bunch of ingredients that have already been developed or are being developed for other purposes, but we're putting them together in a unique way. And this picture sort of shows the basic outline. You got the Cardano main chain off to one side. Then you have the hypercycle nodes, which are arranged in groups, which we call hypercycle rings, which are a special kind of Toda ring. The nodes in a single hypercycle ring have a consensus mechanism to provide consensus about transactions within that ring. They communicate using the Toda IP decentralized protocol. They run Plutus smart contracts, including, when appropriate, extensions to the Plutus smart contracts running in OpenCog's Meta language. And then in the Meta language, you can make DSLs for finance, healthcare, social networking, whatever. And you can even go the next step, and for, say, a finance-specific DSL coded in Meta to run in Plutus, you can then map that finance-specific DSL into lower no-code application development framework, right? So in the end, most developers on this, once it's all finished, most developers should be dragging and dropping and running just little bits of code to create smart contracts running on here. But this low or no code development is in a DSL, which is written in Meta, which plugs into Plutus, which then runs on the hypercycle network. And a lot of transactions can happen in hypercycle with the very low cost and high scale that Toda allows. Then now and then, when appropriate, some of the transactions in the hypercycle network get saved back into the main Cardano network, which, so one role the main Cardano network serves here is as a long-term memory for the faster, more volatile stuff happening in the hypercycle network. Another role could be more complicated. If you have an application running natively on the main chain and another application running on hypercycle, then there can be a lot of back and forth there. So we want to leverage the amazingness of Cardano wherever we can in this, while also doing things that are a little more special for AI, a little more sophisticated on the DSL side, and a little faster and more scalable for our particular applications within the hypercycle universe. So let me now run through each of these components a little bit. Each of these is like a big deep thing that could use a whole talk in itself, but I'll do my best in just a few minutes. So Toda has a few different pieces, right? So there's the Toda IP protocol, which lets you send messages and also lets you send unique digital objects, right? So everyone knows what a unique digital object is now because of NFTs, but also like a dollar bill is a unique digital object, whereas the abstract notion of a dollar is a different thing, right? So the unique digital object can't be copied. There can only be one of them. So Toda lets you send information, lets you send unique objects, and when two nodes in the Toda network send a message and it's encrypted, the handling of the private and public keys is much like in any encrypted network, but the validation doesn't require centralized authority. The validation just involves, and it doesn't require a big ledger of all transactions in Toda. The validation requires the nodes involved in the transaction and some of the neighbors, the nodes involved in the transaction. So it's more fundamentally network-based. It's actually by far the most decentralized blockchain framework there is, because in the end, a replicated ledger is a limited form of decentralization. So a centralized database, okay, there's just only one. than a network like Bitcoin or Ethereum or Cardano. You have a ledger and it's copied all over the place. Or in a sharded blockchain framework, the ledger is sharded into little pieces and the shards are copied all over the place, right? But I mean that is more decentralized than one central database. But in Toda, each node in the network, which is called a Toda file, each node has a Merkle tree recording its own transaction history in a particular way. And the bits in that transaction history are appropriately encoded using the keys of the various other nodes involved in those transactions. But that's it, right? All there is the Toda files with the records of their own transaction histories, and those records tell you who their neighbors are. So it's like it's sharding all the way down, but when you shard a ledger all the way down, you get rid of the ledger altogether, and you just have the Toda files with their transaction histories, doing transactions and consulting their neighbors to validate those transactions via a flexible variety of consensus mechanisms, right? And I mean, there's a bunch of different consensus mechanisms one can use in a Toda network. Hypercycle is doing some unique things here by sort of weaving together proof of reputation consensus with other more computer sciencey Toda native consensus mechanisms. So this is some novel math, which is pretty cool. And if you look in the Hypercycle white paper, you can see links to some online resources on Toda. There's been some sort of reference implementations, which is important. Like we're implementing a lot of Toda stuff in new code, new implementations for Hypercycle, but it's important this has been done before, right? So one example is Toda Q, which is a really scalable and efficient Toda implementation that is intended largely for enterprise applications, so it's centralized in some ways. There's Earth 64, which is a pretty cool NFT related project where you have basically selling off tokenized representations of regions of the Earth's surface, and there's records on Toda. There's been prototype versions of pieces of Bitcoin and Ethereum written using Toda just to see how it would work, though those haven't been rolled out. So we're using some much tested math here in a new implementation that's customized for our purposes. And for consensus, there's a bunch of native Toda consensus mechanisms, but we can also make use of proof of reputation. And I mean, this has been approximated in some existing blockchain networks. If you look at the earlier versions of the NEM blockchain, they had the notion of proof of importance, where sort of how hubby a node in the network was, how much of a network hub it was among all the other nodes in the network, that let you estimate its importance. And then the importance of a node, how much of a hub it was in the network, would tell you whether it got to participate in consensus, right? So proof of reputation is a step beyond proof of importance or proof of stake. You have a pretty sophisticated reputation system where nodes can do implicit and explicit rating of each other, what's called a weighted liquid rank reputation system, developed by myself, Anton Kolonen, and Debbie Duong, and some others. There's a bunch of papers online on that. But if you have a sophisticated way to estimate how reputable, how much of a good actor a certain agent has been in the network, you can then use that reputation to determine how much right that agent has to participate in consensus. And this has pluses and minuses, but it can make a network a little bit hard for new agents to break into, because it takes a while to build up a reputation. And for that reason, it's good to combine it with other methods, like some of the native Toda consensus mechanism. But it's quite a powerful tool. And another powerful tool is Cardano's Haskell-based smart contract language, Plutus. Actually, this is really what got me into Cardano in the first place, because I've been developing in Haskell since like 93, like back before GHC, back before monads, right? And I've seen Haskell get better and better. I'm psyched to see Haskell pulled into the blockchain world by Cardano using it for a smart contract language. I mean, it's highly amenable to formal verification that your algorithm is correct, which is very important if you're going to be automating the world economy or the cognitive centers of the super intelligent global brain. You get very few runtime bugs in Haskell. So I mean, compared to crap like Solidity or WebAssembly, I mean, you're going to get many fewer bugs, many fewer hacks in Haskell-based smart contract system. And the sort of clean morphisms between what happens inside a functional programming interpreter and what happens inside Cardano's extended UTXO framework, it's really quite elegant. I mean, this was one of Charles Hoskinson's big, beautiful insights, right? Is the natural mapping between extended UTXO and what happens inside interpretation of a pure functional language. And the other thing is it's built to be extended very naturally, and we're going to see how this is important when I talk about a little more about what we want to do with plugging the meta language into Plutus. Hydra, the other really cool key piece of Cardano technology. So it's a whole new way to let a main chain interact with external networks, be they side chains or other blockchain networks or whatever thing in between. It's an isomorphism framework for mapping Cardano main chain into other networks. So one thing you can do with it is have an external network of nodes include the smart contracts, but maybe not using the main Cardano network consensus mechanisms. Right now, Hydra itself is a complex beast. There are multiple Hydra heads, which are sort of defined as nodes in the external network that are frequently participating in the consensus or online most of the time. There's also the notion of a Hydra tail protocol where you have nodes in the network communicating with Cardano that may either be offline a lot of the time or busy doing other stuff besides dealing with Cardano a lot of the time. And Hydra tail protocol has not yet been implemented by the Cardano team. It's defined, but some aspects are still sketchy, and we may end up needing to customize Hydra tail protocol a bit for Hypercycle. We've been looking deeply at that, but a powerful framework and meta language as well. So one thing I've been heavily engaged in the last year really is doing a fundamental rethink and redesign of the OpenCog AGI framework, which I think is going to be the software platform in which we make the breakthrough to artificial general intelligence. I mean, OpenCog lets you bring together neural networks, probabilistic and logical reasoning engines, evolutionary learning algorithms, swarm AI, all sorts of different AI methods operating synergetically together on this massive distributed metagraph of knowledge linked to other knowledge, breeding other knowledge. We've already been playing with OpenCog building on top of SingularityNET platform in certain applications such as genomics, for example. We're rebuilding OpenCog into a new version called OpenCog Hyperon to get a more scalable distributed metagraph database running on SingularityNET and to get a more flexible language for scripting AI algorithms and for AI algorithms to use to script AI algorithms, right? And this meta language is kind of a couple steps beyond Haskell. I mean, Haskell is a step beyond standard imperative languages. Standard imperative languages are a step beyond Solidity in some ways, but Haskell's a step beyond standard imperative languages. Languages like, say, Idris or Agda, which are mostly known in the research community, are a step beyond Haskell, and Meta is a step beyond that. It's sort of a language designed for specifying other languages with a type system designed for either user-specified or AI-specified creation of new type systems, right? And, this is important for AGI. It's going to let us formulate our AGI algorithms in OpenCog in a very concise as well as scalable way, making AGI development work a lot easier and a lot more scalable. But one thing I realized is Meta is the perfect framework for creating DSLs and for creating DSLs that are easy to improve and tweak as the world evolves. So what we want to do is take Meta, make it plug into Haskell as an extension, just like we're making Meta plug into Python and Julia for machine learning development. So make Meta plug into Haskell. Then you can use Meta's amazing facilities for creating DSLs to extend Plutus into DSLs for creating smart contracts in vertical market areas like finance, social networks, medicine, supply chain, whatever it may be. And I think this ultimately is how you finally get to a usable blockchain infrastructure, right? Because what you really need is whoever's creating blockchain supply chain applications just to be dragging and dropping, maybe writing a few macros in a low to no code framework for supply chain smart contract scripting. But to do that in a way that's not brittle, that lets you keep updating and improving and evolving the supply chain DSL as the state of the art in blockchain-based supply chain networks evolves. I mean, to do that, you need a quite sophisticated infrastructure for creating, maintaining, updating DSLs, and Meta provides that. So this is a kind of the last funky ingredient fulfilling the hypercycle vision. So putting all these pieces together, what do we get? We get a sort of a sidechain plus, so to speak, of Cardano. Enables huge numbers of AI agents and other software processes to interact on chain at large scale and low cost. I mean, you can specify AI and other complex algorithmic processes in smart contracts using a combination of Plutus and Meta, both languages highly amenable to formal verification and likely to be relatively bug-free compared to smart contracts written using more traditional programming languages. And while all this is really complicated, obscure, and theoretical, in the end, this subtle approach is what you need to make a framework where you can have easily maintainable and evolvable DSL and low-no code tools that make scripting for the blockchain way easier than it is now. So there's loads and loads of applications of all this, obviously, and just to name we've designed all this to meet the needs of SingularityNET, but once we designed it, we realized it could meet a lot of other needs also. So, and in AI context, the main things it gives us is the ability to sort of fractionate our AIs in a more and more granular way across the blockchain, right? Like what we do now in SingularityNET, we take a pretty big AI process using a lot of RAM and processing, maybe running on a network of computers. We make that one SingularityNET agent, and we try to minimize the amount of on-chain transactions because they're expensive and they're slow, right? So if you're running, say, a genetic algorithm that involves a whole population of candidate solutions to some problem, if you're running a genetic algorithm in SingularityNET now, you'll put the whole genetic algorithm population inside one SingularityNET node, right? And that's the only way to do it and not be incredibly slow and expensive. What you could do in hypercycle, if you have 100,000, agents in your evolving genetic algorithm population, you can make each of these 100,000 evolving agents a separate node in the hypercycle blockchain, and then the evolution of that genetic algorithm population occurs on chain in hypercycle, right? And every little interaction in that evolving population of hypercycle nodes doesn't have to be backed up into the Cardano main chain, because some of these may just be stupid things the AI is trying out that aren't suited to be remembered, but the solutions that are really smart and really good that the genetic algorithm population found that are suitable to be remembered, these can be backed up onto the Cardano main chain. And the kind of consensus mechanism you need, say, for running a genetic algorithm population evolving on chain is quite different than the kind of consensus mechanism that you need, say, for underlying the global financial system and sending $100 million transactions from point A to point B, right? Because if you're sending used financial transactions around, you better make damn sure there's nothing that goes wrong. If you're evolving a genetic algorithm population, it may be okay if cheating or mistakes are located only after the fact and not in real time, right? So you don't need exactly the same kinds of security and reliability guarantees for every application there's all sorts of different collections of requirements for different applications. TODA is a very flexible framework that lets you design a constellation of different consensus mechanisms suiting different applications. So I mean, you could have a particular consensus mechanism for hypercycle rings doing genetic algorithm evolution. You could have another hypercycle consensus mechanism for TODA rings doing, say, logical reasoning among multiple different reasoning agents, and different rings using different consensus mechanisms customized for different purposes can interoperate according to the TODA protocol and framework, right? Which is all really quite nice. And because this is all encrypted and on the blockchain, the different population members in an evolving genetic algorithm population could be owned by different people, right? They could be not just living in different places, they could be owned and controlled by different people. So you have a collective learning process on chain among agents owned by different people, collaborating at tremendous speed across a distributed network. And I mean, that's something we can't do now because of scalability issues. We could come closer on Cardano than on Ethereum, but not quite there either, because Cardano's ledger-based infrastructure just isn't really built for that. I mean, it's built for, it's going to be great for automating the world's banking system, right? And for that you need all sorts of really super strong security and reliability guarantees. For AI, we need more flexibility in when we need what kind of security, what kind of reliability, and hypercycle gives us that flexibility. You need the same flexibility to disperse all this processing across all the different processor types in the world, right? So the NewNet framework built on top of SingularityNet, we want to be able to run SingularityNet AI across phones, smartwatches, people's laptops, spare computing cycles, in companies' server farms, on switches and other devices in networks. And if you want to fractionate SingularityNet and other decentralized networks across all these different devices, we need consensus mechanisms and blockchain infrastructure that works really well in this, massively diverse IoT context. You need to be able to define different hypercycle rings, for example, corresponding to different subsets of hardware devices with consensus mechanisms that are appropriate for the properties of networks on that type of hardware device, right? And I mean, all this falls naturally out of the hypercycle design, and you can then go through one vertical market after another, right? Say social networks, rating posts, rating other users in social networks. Again, got to be fast, got to be cheap, probably okay if some mistakes occur now and then and are only detected half an hour later, unlike the case of sending $1 trillion to someone where you cannot make even like 0.1% of mistakes and have them identified half an hour later. So I think, decentralized, democratically organized social networks, decentralized finance, allowing high frequency trading with low transaction cost. I mean, medical networks that interface with medical peripheral devices, getting signals out of our brains and bodies, operating at the speed of our bodies' internal processes and feeding them into signal processing algorithms like we're looking at in the Rejuve network. I mean, there's no end of applications that need, a low cost, massively scalable blockchain framework, which is highly customizable in characteristics to the application. And in hypercycle, we can customize both the consensus mechanisms to the security, reliability, and other requirements of that domain. We can also make custom domain-specific languages using Meta on Plutus to make it easier to script these efficient, scalable applications, right? So I mean, there's a lot of cool stuff here. I mean, if you're a technical person, you will see there's also a lot of work here, right? So I mean, we're just getting started. I've been talking to folks in Cardano ecosystem, along with Tufi and Dan and others in the TODA world, and Anton and others that don't prove of reputation, SingularityNET platform team. We've been understanding better how to fit all these pieces together in an elegant and scalable way. But I think we've got a design that can work here, and it complements everything we've been doing in SingularityNET fantastically well, and also it will allow a whole bunch of other applications beyond what we've been thinking about so far in the SingularityNET context. So yeah, I'm really excited about this. I mean, it's one more layer in the stack, right? You've got the internet, you got Cardano, we got Hypercycle as a Cardano sidechain. We've got SingularityNet running on top of Cardano and on top of Hypercycle, interacting with a bunch of other valuable decentralized networks out there. You have networks running vertical market specific applications like a Singularity DAO for DeFi, Rejuve for medicine, Sophiaverse and in the metaverse, a Mindplex for decentralized social media, OpenCog, HyperOps supplying AGI to all these things, yada, yada, yada. And then a whole bunch of other comparable things created by other developers in the broader ecosystem. I mean, this sort of tech stack is how you bring the whole world economy into the decentralized sphere, which is what we need to do in order to increase the odds that we have a beneficial technological singularity in the next years as we transition from narrow AI onto AGI. All right, thanks for listening to the moderately deep dive of a Hypercycle that I've been able to give in 30 or 40 minutes. If you want to find out more, you can look at hypercycle.ai, where you find the current draft white paper, and there's going to be more and more information, including links to code that are going to be rolled out there as we progress with Hypercycle. I mean, we're just now emerging from the design and deep thinking stage onto the making it happen stage, and we'll be psyched to have participation in various ways as this unfolds, from joining the Hypercycle community and helping with evangelism for technical people, plunging in and helping with the open source software development.